This is Advancements in Machine Engineering. I'm Rebecca Carter. I'm the program manager for STEM Lyceums. Many of you know me. Some of you are just getting introduced. So, hi, nice to meet you. Good to see you again. So before we get started in our programming today, I'm just going to go over some of the basics about our organization and our programs. So the Center for Excellence in Education was founded in 1983 by Joanne DeGennaro and the late Admiral H.G. Rickover, seen here, who is the father of the nuclear navy and civilian uses for nuclear power. The mission here at CEE is to nurture high school and university scholars to careers of excellence and leadership in science, technology, engineering, and mathematics, or STEM, and to encourage international collaboration between and among leaders in the global community. We have 4 fantastic programs here at CEE, the first of which is the Research Science Institute, or RSI. RSI is a highly competitive 6-week summer science and engineering program open to rising high school seniors. Juniors are eligible to apply. RSI is the first cost-free summer science and engineering program that combines on-campus coursework in scientific theory with off-campus work in science and technology research. Then we have the U.S. Biolympiad, or USABO. USABO is the premier U.S. biology education and testing program for high school students. It provides the motivation, curricular resources, and skills training to take them beyond their classroom experience to the level of international competitiveness. Since CEE began administering the USABO in 2003, every member of the U.S. Biolympiad team has medaled at the IBO. Next, we have the Teacher Enrichment Program, or TEP. TEP provides opportunities for middle and high school teachers to connect with leading experts from industry and academia, explore cutting-edge research and development, and make meaningful professional links with direct benefits for teachers and students. Finally, we have STEM Lyceums, which is us right now, a virtual club for high school students to meet once a month to learn about STEM career pathways from leading field experts, 2 of which we have here today. Industry professionals share cutting-edge research and offer unique learning experiences like scholarships and internship opportunities for high achievers. Now I have the pleasure of introducing our fabulous speakers today. We have 2 great speakers, Dr. Shu Wang and Imran Mandani. First, I'll begin with Dr. Wang. Dr. Shu Wang is a smart manufacturing and automation engineer at TE Connectivity. He focuses on enhancing manufacturing process performance and developing intelligent automation solutions that drive business growth and reduce operational cost. His work applies advanced technologies, including artificial intelligence, robotics, optimization, and simulation, to deliver impactful and adaptable solutions across diverse manufacturing environments. Dr. Wang brings deep expertise in industrial AI and advanced manufacturing and has led the development of automation platforms and smart manufacturing solutions that have generated millions of dollars in savings and revenue. Notable contributions include AI-based inspection, continuous process, control and optimization, robotic automation for assembly systems, digital twin modeling and simulation, and smart machine maintenance, which have resulted in over 10 patents and trade secrets. Dr. Wang also maintains an active role in academic research alongside his industry work. He publishes on topics such as advanced manufacturing, operation optimization, and human automation interaction with the Industry 5.0 paradigm. His current research explores industrial AI, engineering design, and human automation symbiosis, aiming to shape future manufacturing systems that are intelligent, efficient, and human-centric. Dr. Wang earned a PhD in mechanical engineering from the Georgia Institute of Technology, where he also completed dual master's degree in mechanical engineering and electrical and computer engineering. This interdisciplinary background, covering mechanical, electrical, and industrial engineering and computer science, together with his applied industry experience, enables him to bridge theory and practice in delivering transformative solutions for modern advanced manufacturing. We are also joined here today by Imran Mandani. Imran Mandani is the Innovation and MPD ProChem Director at the Taylor Station plant for Procter Gamble. A Miami native, Imran received his BS in chemical engineering from the University of Florida. With over a decade of experience, Imran has served a multitude of roles within the realm of machine engineering. He has served as a process engineer, technical engineer, and department leader before rising to his role of director. Imran is passionate about developing leadership, integrity, equality, and inclusion. In his free time, he's an avid golfer, skier, and supporter of Miami sports teams. Woo! Thank you too for joining us. I'm looking forward to these fabulous presentations.
All right. Well, thank you for the amazing introduction. Yep. So my name is Imran Mandani. I've been with Procter and Gamble for just this June will be 12 years. Like she said, I'm born and raised in Miami, Florida. Support all the Miami teams. Studied at the University of Florida. Got a chemical engineering degree. I also did minor in electrical engineering and packaging sciences, but I don't advertise those two as much. And then yeah, so some of the roles that I've had while I've been with Procter and Gamble, so process engineer, technical engineer, project manager, and in a lot of those I was dealing with putting liquid in a bottle. Then going to North Chicago where we make the actives that go into Old Spice, Secret, Gillette for the anti-perspirant, and then Head and Shoulders for the anti-dandruff, and then the antibacterial that goes into Dawn. And then once I became the department leader, I then had the uh, personal care brands from Old Spice, Olay, and Ivory, and then transitioned to the hair care brands where I was over Herbal, Pantene, Aussie, and Head and Shoulders. And then now, as the innovation and MPD ProChem director, what I do is seeing different ways that we can innovate our current design, and then also from a raw material standpoint, how do we optimize and use all of our materials efficiently and to its maximum capacity. So how do we do this? So the way P&G manufacturing does work is through something what we call integrated work systems. And in this, we have 10 pillars where we go through, basically, this is how P&G manufacturing does work. And it all starts with the bedrock principles of, respect for all individuals, having strategic work focus, the company and the individual's interests are inseparable, right? And then through that, we're able to gain technical mastery, add personal value, and then externally focus on our product to make sure that we're able to get it out in the market. So this is something that we've practiced. We even sell this to other companies, and so to be able to do this, right? How did IWS come about? So we started in the 1960s where we use high performance work systems, bringing in total quality, bringing in statistical process control. Like these were all, known processes, reliability engineering, time-based maintenance, having a reliability focus, and then bringing end-to-end supply chain optimization and lean manufacturing while integrating Toyota manufacturing principles. And so through the combination of all of this, we have called it integrated work systems. And this helps us to go through our supply chain from end to end. So think of this, right? When the airline industry, when they go from planned stop to planned stop, they don't have any unplanned stops in the middle, right? So that's going from airport to airport without stopping in the middle for any reason. And how are they able to do that? They have a zero defect mentality. And so similarly, so let's look at that defect mentality. So if you've been on a plane before, you may have, if there's like a defect, the little call button to call the attendant isn't lighting up. Or let's say the recliner on your seat is not functioning because prior to takeoff, you're supposed to have it in the upright position. When you think of all these different things, none of them actually go towards the functionality of the actual plane taking off and landing, right? Like the little light bulb, the recliner, those aren't going to impact it. However, they have this zero defect mentality that allows them to ensure that from end to end, they will not have any issues going from airport to airport, from planned stop to planned stop. Similarly, if you look at cars, a lot of us may be driving cars or starting to learn how to drive. And as you get to, know the functionality of your car, you're going to understand, oh, you have to refill the gas. Every so often, you're going to have to change the oil. change the wiper blades, look at your tire pressure, different things like that, right? And so these are some of the day-to-day activities that we would do to then enable trying to get, to ensure that the reliability of that car is going to last what it's supposed to. So let's say the car is supposed to last you 15, 20 years, that it actually lasts that 15 to 20 years without breaking down and having engine problems and things like that, right? So there's various maintenance activities that you would do to be more preventative rather than reactive. So we at P&G have taken this concept, right, and with what I shared previously with IWS, bringing all of that together allows us to have, the productivity that we want. Now, a lot of you, if you're familiar with the scientific process, right? So when we have all these short-term and long-term strategies to ensure that our equipment is running properly, we implement and ensure that we're also following the scientific process. So how does the scientific process start, right? You observe a phenomenon, you ask a question, a problem statement. From that problem statement, you want to create a hypothesis where you've laid out, the variables. You're trying to understand, how can I isolate this variable? Then you're going to make a prediction to say, okay, this is what, if I make a change, then what is my expected result? Because, and then you're going to bring some science into it. But then to do this, you're going to test your hypothesis to see, can I turn this problem on and off? From that, you'll draw some results, create your conclusion, and then see, how can I reapply this elsewhere, right? Like, what are the learnings from this that I can then take to the next level? So for us at Procter & Gamble, what we do, we also have a loss elimination strategy where we have a large vague problem. We would come up with a refocused problem statement. And then we have similar tools where we have Fishbone. This is where we lay out, okay, what are all the variables that are contributing towards the problem? We then use our cause and effect, which is essentially taking a thesis, a hypothesis, and saying, okay, how do I isolate one of these variables to be able to get to the root cause? And then from that, you'll draw your results and conclusion. And then we do an analysis, two different ones called why it happened and why it passed. So the why it happened is the science, right? Like, oh, this had a lot of vibration and it got loose. And then as a result, gravity took over and it backed out. Okay, that's one example. But then systems is then, how did we allow that to get to that point, right? When I was talking about the airline industry, what checks could we have implemented? What could we have looked for to prevent this defect or this breakdown from happening? And we do that through what we call autonomous maintenance. And autonomous maintenance is pretty much our strategy for our short-term strategy to be able to ensure the reliability of our equipment. Now, we at P&G, we pride ourselves in saying, from like a technician standpoint, you do, as long as you're able to have the problem-solving skills, then you'll be able to, thrive in the P&G world. Similarly, though, when we talk about careers, right, there's mainly our engineers come from, our managers come from the engineering side. And this is where we are taking a deep dive to understand the root cause of some of our issues. And some of the types of engineers that we hire are chemical, mechanical, electrical. And then in addition to that, we may have industrial or not as many of the other disciplines, although we do have many that are not of the ones that I mentioned. And then because of their ability to just problem solve, they're still able to work in a very mechanical or electrical, chemical type of environment, right? So a lot of our machines are very mechanical based. So now, okay, we have integrated work systems, right? This is how we're able to take it to the next level. But within our plants, we have 5 levels of this. And so the 5th level is where the magic happens, right? This is where we bring in automation. This is where people's capabilities are going through the roof. We have aspects of digitization happening. And together, this allows us to then innovate our supply chain end to end for synchronization. So that way, when the customer, like Walmart, says, hey, I want X amount of Tide or X amount of Head and Shoulders, we're able to react quickly all the way to make it to their shelf. And then that's where the consumer, all of us, we then, would purchase and then consume that product. Okay, there are elements of robotics and cobots, right? Cobots are have half human interaction and half the robots are doing some of the mundane movements. Um, Grippers, 3D visioning, allowing us to be safer in the work environment. Starting with different types of robotic hardware and software, new technologies. So right now we have AGVs, auto guided vehicles, that pretty much bring raw materials to the plant and take away our finished product to the warehouse. So our people are doing more of the thinking on how to make the process more efficient, how to leverage the technology that we have so that way they interact less with the equipment and are more there to understand, okay, are we producing quality product? How can I optimize the system? What are ways that I can eliminate losses and reduce our total plant costs? So these are different things that we would then look from end to end. So then we have things called platforms. So we have similar equipment across different sites globally. And then that enables us to, if we have a change here on one piece of machine, how can we leverage that learning and reapply it quickly to the globe? So then that way, like, let's say we're making Head and Shoulders here in West Virginia. So then if we learn something through our, improvements, okay, we also make Head and Shoulders in China. We also make Head and Shoulders in Europe, right? So how do we then, whatever learnings we have here, quickly reapply it through the platform? So then that way all of our sites get that instantaneous change, and then now the same improvement is reapplied, and everyone reaps the benefits. And then we have a digital ecosystem through various Power BIs and data analytics and dissecting data to allow us to really spend less time on the data analysis, on understanding the data, and more on, okay, what are we analyzing with this data? How am I taking this data to help me in the decision-making process to be able to go faster, quicker, more efficient? And we also have, elements of AI where so just like how I was saying with Power BIs, but AI is also able to take larger amounts of data, package them into different models, see how we can reapply them on the line, and then through actual human observation, we then reuse whatever was started from that model, and then how can we tweak it? What needs to be true to then make it fully self-sufficient, and then reusing it so that way we can reapply it across. And so what does that really mean? So today, we have our traditional humans are, stacking boxes. We have different operating strategies from site to site. And from our manufacturing, everyone's doing it a little bit different. With all of these changes that I mentioned, it allows us to have a better supply chain, have better operating strategies, and then we're able to now focus end to end to deliver, what we need, which is ensuring that our business doesn't go stale in the market, and then that we're still having a competitive advantage when delivering our end-to-end products. So that's the end of what I have from a content standpoint. But this is, when I look at, all right, cool. So when I look at, P&G manufacturing, this is how we're able to take some of the technology that's out there to really reapply it in a very meaningful way. And then that allows us to work more efficiently, safer, and having to do less rework. So then we're able to execute the first time and not have to keep retouching and trying to optimize it thereafter. So really, the focus is always on getting it right the first time. And so coming back to some of the career paths that we have within P&G, we pride ourselves in saying we can hire anybody, and through our education and training systems, we can build you into the technology expert, and whether that's you have an engineering background or you don't have an engineering background. So definitely those that go towards the engineering path, they'll end up, especially in P&G, the way our ranking system goes, that's how you would come in as a manager. Otherwise, you would start at the technician level. But I've seen many technicians who sometimes outpace the managers, especially towards the end of their careers. They're making more and contributing to the business at a high level compared to some of the recent college grads, right? But that doesn't take away from those folks because they also have a longer runway to then perform against. But yeah, so that's a little bit about me, about Procter and Gamble, and some of the AI automation that we have going on, especially to make our machines more efficient, our lines more efficient.
Thank you, Imran, for your presentation. One phrase that comes out to me from that is "work smarter, not harder." It seems like P&G is working on that phrase right there.
Yes, for sure.
All right, thank you so much. We're going to turn it over to Dr. Wong.
Hey, my name is Shu, and currently I'm a smart manufacturing and automation engineer in T connectivity. Thanks to CEE, today I had the honor to introduce and share my opinion about advancements in machine engineering. So today I want to share 4 points, including the core disciplines involved in machine engineering, the academic pathways, and also I briefly talk about engineering roles in industry, how the idea become a product. And lastly, I will briefly talk about the industrial AI in smart manufacturing. The first question I want to kick off today's discussion is, what is manufacturing engineering, machine engineering? So machine engineering can be defined as a interdisciplinary field of engineering, and the objective is to design, develop, and improve the operations of a mechanical system or machinery. Let's take an example of the bottom right image, where different robots assemble the products on the production line. And here, there are actually a lot of engineering disciplines are involved. Firstly, it's the mechanical engineering, as well as the material science and engineering. For the mechanical engineering, you can see the gripper, the structure of the gripper, how the gripper can pick up the parts. That uses the mechanical engineering. And for material science and engineering, that's how the material of the gripper can be designed, as well as the joint of the robot. So these materials determine the capacity that the gripper can take, and also the capability of the robot. What else do we have? We also have the electrical and the electronics engineering, as well as computer science. So electrical and electronics engineering in the automation or manufacturing side usually focuses on the control and also the wiring of the electrical wires. And computer science does the programming of the robot and also sometimes the control of the process. And apart from this, we also have the industrial engineering and the manufacturing engineering. Industrial engineering designs the layout of the whole production line, while manufacturing engineering can decide for each manufacturing processes what are the details of those. Then I would like to start the introduction of a little about me. So firstly, it's about my academic background. I initially started the academic journey from electrical engineering, where I learned the control theory and the circuits. Then I go to Georgia Tech for the graduate, where I had a degree in computer engineering and also industrial engineering. So for computer engineering, the focus is in the AI and specifically the computer vision. For industrial engineering, the objective is in the operations research, which is to optimize the system settings to improve the system performance. And lastly, I had my PhD degree in mechanical engineering, and the focus is in the manufacturing systems. And look at the other side of the journey. In the industry, I also had different roles, including the software development to develop the software, operations optimization to optimize the operational system, such as the airport staff scheduling. And I also worked in the manufacturing automation team to build automation solutions for manufacturing customers. And now I primarily work in smart manufacturing, which is to use advanced technologies such as artificial intelligence to improve the efficiency and reduce the costs for manufacturing. A question that I was often asked by the students that we collaborate in school is, how do I choose if I want to do just a bachelor degree, or do I need to read a master or even further PhD? I usually tell them the decision depends on where you position yourself to be. And that depends on where you want to work in the future. If you want to work in a conventional and manufacturing and automation company, that requires a bachelor degree, and you can start the engineering journey directly. What is taught in bachelor degree is the core engineering principles, such as the foundation of the programming and the robotics. And you will also practice your problem-solving skills in bachelor degree. If you find the challenges or the problems you are addressing in bachelor degree is not challenging enough, and you want to try something more challenging, then you can think about reading a master degree. And in master degree, you will learn more specialized technology. And this includes the advanced robotics, and specifically AI artificial intelligence and data analysis, or simulation and optimization. These skills and knowledge can help you to join a research and development team in manufacturing company, and you can also lead small technical projects. And usually, if you want to become a professor, or you want to lead the innovation or the R&D process, or you are passionate about inventing solutions for the real-world problem, you can read a PhD where you will learn how to conduct original research. There are a lot of things you will learn in the PhD degree, such as identify what is the critical challenge for all the problems. You need to have the ability to generalize the problem into an abstract problem. And after that, you need to think about how to create innovative solutions. Apart from that, you will also learn how to write and publish papers. And in the same time, you will also mentor other undergraduates or the master students, and you will begin teaching each other. And lastly, you will have the skill for lead the innovation development because of the projects you experience in the PhD degree. And next, I want to discuss a little about what is research and why does it matter. I'm talking about this topic from three perspectives. One is, what do researchers do? I remember my advisor told me research is actually search and research. What does it mean? The first step, search, is actually to understand what are the existing problems. And this is done by reading a lot of papers. The problem you try to solve usually comes from the existing formulated one, which is from the previous paper that identified the problem as a challenge. this is the search process. Research is to after we get this, after we have a formulated technical question or research question, we are thinking about approach to solve that. To do research, you need to know how to ask the critical question, what is really important for the problem to address, and then to create the new knowledge based on the research, based on the searched papers and the other knowledge that you learned. You integrate those and generate new knowledge. And the second point here is what makes good research. So good research should guide the advancements in practice. Take the one example in manufacturing side is the modular design. So the proposal of modular design actually helps the mass production in the last decades. And the third point, I would like to take a few examples of research topics in machine engineering. This includes the human automation collaboration and the reconfigurable production systems. The two topics listed here are actually have a lot of motivations based on the existing horizon of the manufacturing industry. With the advancements of the automation technologies, the capability of automation becomes higher and higher. And on the other side, there needs to be human in the loop to control and intervene the automation capabilities. And on the other side, for the reconfigurable production system, that's with a lot of variety in product family, in different products in the same product family, or for a manufacturing company that needs to manufacture high mix and low volume products, they need to think about how to reconfigure the production system to enable the manufacturing and production of different products. So those are all worth topics that worth studying. I would like to take one example further to illustrate the human automation interaction, which is the Industry 5.0. So you may have heard the Industry 4 in the early 2010. And the whole scope of the Industry 4 is 4.0 is to enable a cyber physical system, meaning different machines will have the sensor and the status data connected to construct a Internet of Things network. And by using big data and artificial intelligence technologies, we can have good control of the whole manufacturing system. And what is added in the Industry 5.0 is what I just mentioned, the human in the loop. This is because people find with advanced manufacturing technology itself, sometimes there are failures that happen in the system. And if the automation level of automation is very high, the failure may be difficult to overcome. And at this point, human became a critical role. And so the Industry 5.0 is to consider how to include the human dimension in the existing cyber physical system proposed in Industry 4.0. It is about to propose a human-centered approach and how to design systems and processes to work with humans. And I would like to take a few minutes to talk about the industry side. And this is how ideas become real products. And I'm going to talk about this from the operation side of a manufacturing company that makes products. So we can categorize the roles in making idea into a product into three categories, including the new product development engineer. That role is to define what the product is. The manufacturing process development engineer, they will work on and figure out how to make the product, and manufacturing engineer who runs and maintains the manufacturing process. how do they collaborate during the process to make the idea into products? There are usually 5 gates that are defined in the life cycle of a new product, including the definition and concept, design, validation, industrialization, and production. So in the first gate, the objective is to define the idea of the product and draw the early sketches. This requires a lot of domain knowledge, and this is where the new product development engineer works. And then the next gate is design, which is to have the specific engineering drawings and the specifications of the product. And this is where the new product development engineer and the manufacturing process development engineer work together. And the third gate is the validation, which is to test the build and conduct the feasibility trials for the design that's proposed in the gate 2. And this is primarily done by the manufacturing process development engineer. And then the industrialization is to study how to build the tooling and the line setup for the whole assembly line or the production line. And this belongs to the scope of the manufacturing process development engineer and also the manufacturing engineer. And once the production line goes into production, it will be run by the manufacturing engineer for daily production and troubleshooting. So let's then look at how industrial AI is positioned in the smart manufacturing side. Manufacturing is a business, and what do factories want? They want to have the faster and cheaper, safer production. On the other side, as factories get more advanced, managing the operations of the manufacturing system becomes very complex, and this is where industrial AI can come in. We are looking at this problem in different levels. So in the plant level, AI can help manage complex operations. In the production line level, AI can help the control of and optimization of the processes in real time. And in the single station level, AI can help maintain fast speed and high quality production. And in the product level, like development of a new product, AI can also help design and launch new products faster. So industrial AI aims to help the factories become smarter, faster, and more human-friendly. Before we get further, one comparison I would like to make is the difference between academic AI and the industrial AI. I believe during the study of the computer science, a lot of students will have a basic understanding about AI, and the AI learned at school, as it can be categorized into academic AI. So what's the difference? We can look at that from different perspectives. Firstly, from the purpose perspective, academic AI is about explore theories and create new algorithms. On the other side, industrial AI is to solve the real-world problem and improve operations in factories. This is like academic AI is to build the tool that we can use, and the industrial AI is to utilize the tools that's developed in academic AI and to use that to solve the real problems. And from the focus perspective, academic AI aims at accuracy, novelty, and the best possible results. On the other side, industry side focuses more on the AI algorithms, reliability, speed, scalability, and also return on investment. So this brings different success metrics to the comparison. Academic AI focuses on the research impact and publications, while industrial AI focuses in the business value and the real-world improvement. And looking from the problem types, academic AI addresses new algorithm design, theoretical modeling, and also benchmark comparisons. And for the industrial AI, it is to deploy the existing AI algorithms to the problems and adapt AI algorithms to production problems. When we think about how AI can be utilized in the industry, especially manufacturing, one thing we need to know is the common data modalities in AI. And once we know what kind of data can AI be utilized, we can identify new problems that will help improve the manufacturing process. So common data modalities include the numerical data, the image data, natural language, audio, and the graph data, as well as the time series data. So numerical data in manufacturing perspective is more about identifying the relationship between the input and the output. Well, image data sometimes can be more seen. This is a wide application where AI is utilized is to use the computer vision or machine vision to achieve automation, inspection automation. And natural language is one good example of natural language is actually the large language model, and different AI agents can help utilize the technologies in natural language to automate some robotic processes. And audio data is the information from the sound, and there are also algorithms to address the analysis of the audio data. Graph data focuses on the relationship and the entity types of different components in the manufacturing industry. And time series data is also very common in the manufacturing side, just like the sensor data you collected, and you are using the sensor data collected to do the predictive maintenance for different machines. And lastly, let's look at a few industrial AI applications. The first one is the AI-driven design generation. So, like I mentioned just now, AI can help the design and launch of new products sooner. How does it do this? We can use the generative AI, and we specify what the requirements of the new mechanical component needs to be. And we will specify a few constraints, like what the material is. Then AI can generate the solutions of several feasible design automatically. The second application is to do the defect detection, and this is commonly used in different industries. So the conventional convolutional neural network is usually used here to do the image data analysis. AI can also help the process control and optimization. By using the time series data, we can control the machine smartly or use numerical data to determine the machine status and make corresponding actions. And AI can also help us to do the production planning. This is also one of the AI's capability, and to solve the supply chain and also the manufacturing planning and scheduling problems. So this brings to the end of my presentation. Thank you, everyone.
Thank you, Dr. Wong. It was a wonderful presentation. I love that intersection between academic and industrial AI and seeing where those overlaps are happening. We're going to go ahead and open up to the Q&A. So if you have a question, please put it in our Q&A section. While we're waiting for those to come in, I will start us off. So this first question goes both to Imran and Dr. Wong. So AI is developing very quickly. How do you keep up with those quick changes and implement them in your organizations to stay on the cutting edge?
Yeah, I can start with that. So, can you guys hear me?
Yep, we got you.
All right. Yeah. So for us, right, like we have some AI tools that we've then taken to then integrate into our own work. So that way we're not, also putting our company secrets out there. So then that way, like let's say Chat GBT is just able to then take it, and then, now that it has this information, it can leverage that as data when trying to answer someone else's question, right? But in turn, it could be giving away some of our secrets. So we have something where we have a similar Chat PG instead of Chat GBT, We also have like an image PG, like it's an image generator type thing. And then we have another one called Ask PG, which is like it is looking at all of our databases of everything, P&G documents and things like that. And so if you ask it, hey, how do I do a changeover, or what's needed to reduce, and if someone has already done this work in the past or has proven it, you don't have to go scouring and trying to find, who did it. Our Ask PG system or AI can then just look and find it. We've got a couple other ones as well, to where we're actually embracing it rather than saying that, oh, it's gonna prevent us from being more efficient and things like that. So I think in my company, we're actually leveraging it to give us a better competitive advantage.
Awesome. Thanks so much. Dr. Wong, do you have anything to add in on that, staying cutting edge when it comes to AI advancement?
Yes. Um, Thank you for the question. I think for the AI technologies, like the new technologies, usually there will be two teams or two actions for this deployment. One is the absorption, and the other is the execution. Or usually from the manufacturing side, there will be a technology team and also a operations team, and the technology team can absorb what is new in the AI industry and evaluate different AI solutions and also suppliers. And then they will start small and begin testing those AI suppliers or technologies. And then it will be the execution of how to deploy and also scale up those AI opportunities. And about if we are taking the some of the technology, that I think that depends on the strategy that the company take. And taking the large language model, for example, the generative AI, when it is launched in 2023, there is a great discussion about if generative AI should be applied in the company. And there is a report in Harvard Business Review about if people compare to not taking AI or generative AI and to execute that, people are a lot less worried. Actually, when comparing taking the risk of failure from taking the action of using the generative AI, that is actually more acceptable than not chasing the generative AI in the manufacturing side. Yeah, that's what I want to add. Thank you.
That's fascinating, that point about how it takes the onus away from the person and now it's on the machine instead. We have a question here in our Q&A from Hector. Are there any drawbacks to leaning to automation as it becomes even more prominent? Are there any drawbacks that could develop in the future? So any barriers that we're seeing for engineers in the future as progression happens?
I think a part of it starts with learning how to deal with it, right? So, we've got lots of automation all over, especially with robots and co-robots and things like that. And so, hold on, let me go back to the question. So, drawbacks, right? Um, I think the initial drawback is learning about it and becoming a master at it, right? But then it's it's then the job, then instead of us hiring people to do mundane tasks, stacking boxes, putting stuff from point A to point B, right? Or using forklifts to take, something from here to there. Um, Leaning on automation initially can, you have a ramp up, but once you get ramped up and the systems are working and we know more about the equipment, we're able to understand the reliability aspect of it, We're able to understand how to maintain that equipment. So now our machines, our equipment, instead of it being, let's say, like an assembly line, right, where everybody has one task or two tasks and they're, doing that part. Now the robot, the automation is able to do that repetitively, accurately. But so now the person, right? It's not like, so at P&G, once we hire you, we hire people that are for their problem solving skills, right? We're not hiring you for the job. So initially you may start off like how I started off as a process engineer, right? But then you might turn into a technical engineer or a project manager, from the people aspect, a department leader or an area leader or things like that. And so it actually gives a competitive advantage because now that you have this digital skills, this automation skills, you're able to pick and plug this person into different environments to then help optimize that area. So now our focus transitions from hiring people that are just gonna do some of the automated tasks versus having them troubleshoot those robots, having them to understand how do those robots work? How do we, so now the skill set goes from a little bit mechanical to more electrical and process control.
Awesome. Dr. Wong, do you have anything to add on that effect?
Yes. So we can think about if we are leaning to automation as a decision of investment. That said, two drawbacks I can think about automation. One is the cost, and the other is the flexibility. From the cost perspective, automation is expensive, and usually if the product does not have a high volume from the customer, they would not invest in the beginning with the automation approach, and they will start small by using the manual manufacturing. And similarly, for the flexibility, the manufacturing process can be complex, and for different manufacturing of different products, for a single part number, the manufacturing process, it needs to be designed specifically. And if we are to automate the production of several products, that means when we want to do a manufacturing for other similar products, a lot of things needs to be changed. And that's also the drawback of automation. And yeah, that's are the 2 points I can think of for the drawback of automation.
Thank you so much. I want to add in on that because Imran had mentioned about those problem-solving skills and looking for people, students, graduates that have developed problem-solving skills or that flexibility of mind. Are there any recommendations on how our high school students could practice developing those problem-solving skills? Are there any activities that might be useful to them or things they can do?
Yeah, for sure. Like kind of like how I was saying when I was presenting, in terms of the scientific approach and the method, right? To see if you're able to practice in that space. I know when I was in college, there were different robotics clubs, and then there were also different, competitions where you had to build a car or you had to build something, and it was like, okay, where does who was able to take the car the furthest or had the fastest speed or something like that, right? uh, some of those clubs and groups now, instead of going towards, hey, let me just think of like the mechanical engineering or, the electrical engineering, let me think of drag, all the different forces and how it applies, instead of looking at that, leveraging AI or leveraging some of the automation tools to then help. That's another way to get exposure, especially if it's through a school or a club. There's always some type of sponsorship that has some of these tools available. So I would, implore people to join some of these clubs and, STEM groups that are already doing this. And then also once, you do get into higher education, or if you choose, different internships that can give you a taste of, how to do some of this, because then that in the end will make you a better candidate for, companies like mine, like Procter and Gamble, when we go to recruit.
Awesome. Dr. Wong, any recommendations for problem-solving skills?
I think I agree with Armin. So we can start from small projects, and actually automation and problem solving is a soft skill. And whatever the problem you address, you can normally you will need to analyze the or generalize the problem and identify what may be the correct solution. And by trying from small different example, you can accumulate the knowledge in different domains. And I think for automation team, innovation is a key characteristic. And how to get that type of innovation is to being curious. And being curious means you anything you see in real life, you don't know how it is made or how it runs. You can begin to study that yourself, and that can let your knowledge grow and accumulate different knowledge. Like I said before, automation is a collaboration of different engineering topics, and as you get more knowledge in different projects or different problems, you will also have better problems solving skills by having experience in different problem domain. Thank you.
Awesome. So, to encapsulate what you both said, it's kind of developing that creativity, that, ability to collaborate and discuss with others that are kind of tackling the same problem, and getting that hands-on experience too, just getting in there and trying. Beautiful. I have a question in our chat over here from David. Are there any legal considerations? I think we kind of touched a bit about this on, your proprietary knowledge, legal considerations associated with the shift towards AI use and manufacturing solutions.
Yeah, and that's where I was talking about, right? That's why we created our own chat and ask tools, because if that information gets out into the public, then all of our competitors can just shamelessly reapply, and then now we don't have a competitive edge. So definitely there are legal considerations from that standpoint. But at the end of the day, like if you're using AI or like some type of chat type system to get some insights, someone else was talking to me about this is AI chat, different tools are available everywhere. For students, how do students then not cheat or copy and paste what AI is telling them for some of their reports and things like that? So I think it also goes on to from a teacher standpoint, to make some questions that say, oh, how does maybe your personal life relate to the problem in this situation? So now you have to, right, draw on personal ideas. But in terms of from a business standpoint, yeah, like there are legal considerations, and that's why we've created our own tools.
I think Imran made a very good point. One thing I want to add about the legal consideration is the use of AI for facial expression recognition. And that's commonly seen in AI exhibitions. You will see different cameras are put there, and different algorithms are used to capture how your emotion is like just in real time. And I think in the US that that practice may not be legal because of the portrait right, and that's another legal consideration we need to think about when developing the solutions. Because in the manufacturing side, the AI, especially computer vision, can analyze the operator action and to monitor their efficiency. So that's where the legal issue may be generated.
Thank you so much. And thank you all for your very thoughtful answers and taking these questions. I know we have some in the Q&A. I got some myself, but I want to make sure we respect our time for the session and we keep to our schedule. So I'm going to go ahead and move us to our closeout. And
If you
then,
want, I can answer that last question real quick
sure, go
because
ahead.
it's a quick one. So what did it say? It said, how does HR look for what does HR look for in an applicant? How could HR differentiate perspective versus less perspective? Okay, so for this, right, for us and for a lot of companies, HR is just setting the interview up. For the most part, the hiring manager is going to be someone from a technical standpoint or someone that's in the field, or right, because that's going to be the person that you're reporting to. So for the most part, HR is just there to set up the interview. It's then on the technical person who's doing the interview to then pull, how can this person be a fit in manufacturing? All right, that's all I got.
Thank you. Dr. Wong, do you have any add-ins for that or?
No, I don't have anything to add. Thank you.
Thank you so much. And thank you, Imran, for taking your time to answer that last question. If anybody has any additional questions, please feel free to email me. I'll pass them along to our speakers once our recording is put together and we do our closeouts. I'd like to thank our sponsors. Of course, I'd like to thank TE Connectivity and Procter & Gamble, who have been represented here today in our session. And then a special thanks to the Cloudmore Charitable Foundation. Once again, thank you to Dr. Shu Wong and Imran Mandani for joining us. And please consider filling out the post-webinar survey in our QR code right there. Your feedback is always welcome. We're currently planning our fall sessions, so I want to hear what you're looking forward to, what topics you'd like for us to cover, and what you'd like to hear more about. Thank you, everyone,
Yeah.
for joining us and taking the time.
Thank you.
Thank you so much.
Thank you.